All right. So the beginning of this says work with a partner. I cut a little bit of it off. And it says the functions f and g are inverses of each other. Compare the table of values of the two functions. How are the functions related? So how are our functions related? Today we're talking about inverse functions. Yes?
So I think they're related because so f of x, it's like it basically opens up and that g of x opens down. So it's like the same thing. It's just one's going up, one's going down.
Okay, Chris?
From the table, I got that from the x for the first one, it's the g of x in the second one. So they're kind of flipped.
So for the x in the first row, he's noticing are all the same thing as the y in the second row, or the g of x. And what else do we notice in conjunction with the x being the y in the second one? Ben?
They're both the same origin.
Going back to what Chris is saying, what else are we noticing?
The y is also the x.
Did you notice that? So you should be noticing that here, this is the y. And here, this becomes the x. So when you have an inverse function, you switch the x and y's around. Does that make sense? The same thing's going to go if I had ordered pairs. Like 0, 1, 2, 3, and 4, 5. In this relation, the inverse relation would be what?
1, 3, 5,
Good. Is that making sense? All right. So, oops. Okay. So, now, let's look at our graphs here, guys. Let's look at our graphs. The next thing it said was plot the points. Now, it didn't say just do a few. It said plot the points. So we don't really have an option to just do a couple. Okay, so the first one I'm going to do 0, 0. I'm going to plot them in two different colors. The second point is 1/2, and then I'm going a half over, and then a quarter up. You see that other little dot? The next one is 1, 1. Okay, the next one is 1.5, and then I'm going to go 2 1/4 up. You with me? All right, so now I'm on 2, 4. Okay, then I have 2.5. I go halfway between the line, and I go up to 6.25, right about there. And then I go to 3, 9. And then I'm going to 3.5. And then I go up to 12. 12 1/4. And I connect that with a smooth line, as it says. And you will notice, oops. That's supposed to be smooth. Boom, 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 boom. I want you to see my points. Okay? If I do the other one, and we said that that one was called which function? That's your f of x, right? So I'm going to do the other one in blue. And the other one in blue, I'm doing the same thing. So I'm going 0, 0. I'm following the table. And then I'm going to do 0 1/4. Going 1/4 across, a half up. Then I'm going to 1, 1. Then I go to 2 1/4, 1.5 up. Then I go to 4 up 2. You with me? 2.5, and then I'm going to 6 1/4, and then up 2.5. Then we go to 9, and we go up 3. And then we go to 12, about 12 and a quarter, and then I'm going up 3.5. And I connect it with a smooth line. Okay, this is my g of x. All right, so your graph should have looked something like that. Okay, tell me what we notice about that. Nice and loud so the recording can hear. I'll repeat what you say, Caleb.
So basically the graphs are, so f of x is basically the same thing as g of x, except it's closer towards the y-axis, and g of x is the same thing as f of x, except it's closer to the x-axis.
Okay, what do you think, Jairus? So he said they're both the same, but the f of x is closer to the y-axis, g of x is closer to the x-axis. You think the g of x is?
I think it stretches away from the y-axis.
And the other one stretches away from the x-axis. Okay, but what about compared to each other? Yes.
Compared to each other, they're basically the same.
Except, Dariush?
The x-axis and the y-axis are like flipped.
We just talked about the, okay. Okay, what else are you noticing? Okay, they're the same. What do you mean they're the same? Yes.
It's kind of like flipped to the side and then it
Oh, it's not flipped, but it's,
Reversed.
what?
reflected.
It is reflected. What is it reflecting over?
The x and the y-axis.
It's not reflecting over the x-axis, and it's not reflecting over the y-axis.
Reflecting between x equals y.
Yes, it's reflecting over this line, which is, I'm going to just, x equals y right here. Do you see that, guys? So what you are seeing is this is reflected over the y equals x. Okay? You will see I kind of drew it and I did the little dots here on my own. Now, one other thing I want you to notice is notice that these 2 points right here, from here, oh, let me go in a different color. How about if we go to yellow? Okay? From here to here, it's equidistant across y equals x. Same thing here, and here, and here. Do you notice that? So when you have a function and you're looking for its inverse, it will be equidistant from y equals x. Does that make sense? Now, remember what we did in the tables? What did we do here? This became the y, and this became the x, right? Okay, so now we're going to do a problem, and let's take an equation and find the inverse of it. Okay, so if I have let's say, y equals 2x, how do you think we'd go about solving that to find the inverse function? Yes.
Would you make the table first?
No.
Would you find what x is equal to?
No. What did I do with the relation or in the table?
You could just do the inverse.
What did we do in the table every time? Yes.
You did the opposite.
Close. Yes.
You reverse the y and the x.
Yes, we switched the y and the x. We switched them, right? And so it became x equals 2y. And then guess what we do? We divide by 2. We divide by 2. Now, I know this isn't a function because it doesn't say the f of x, but I know that it's easier for you guys to see it in y and x form. So now I've got y, and once I switch the x and y, I solve for my y, and I get x over 2, and that is the inverse function. Now, we have a very special way that we write inverse functions. So normally this would be the f of x, right? Equals 2x. Well, I switch it. First, I temporarily take that y and make it y equals 2x. Then I switch my x equals 2y. right? Then we solve, and then we get y equals x over 2, or 1/2 x, right? I'm going to turn it around. Y equals 1/2 x. But you have this, to show that it's an inverse, you do the f, the inverse function. It looks like an f and a -1 up high of x is equal to 1/2 x. Okay, do you understand this symbolism? So now I'm going to write down the steps. Ready? Can I erase this? Can I move on? Okay, so step 1. Let's take number 1 in tonight's homework. You should have a worksheet. It says the g of x equals 4 minus 3 over 2x. So number 1, you write the original equation, or the original function. Number 2, I like to just switch it out for y and x. Which really, this is optional. Okay? Now, step 3, what did I do? I switched x and y with each other. Switch x and y. So I'm going to write it. I'm going to say x is equal to 4 minus 3 over 2 y. And number 4, I have to solve for y again. Okay. So I start peeling it away. Minus 4. Okay. I get x minus 4 equals -3 over 2y. Now I'm going to multiply by -3 over 2, -2 over 3. And cancel, 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 cancel. Oops, and when I distribute, I get -2/3 x minus plus 8 over 3 equals y. Or I could write it -2x plus 8 all over 3 is equal to y. But if I write it in inverse function form, I'm going to have to, instead of for the y, I'm going to, number 5, we are going to write it as an inverse function using f to the -1 of x, or g if they use g. So this happened to be a g of x, so I'm going to write it the g to the -1 of x equals -2x plus 8 all over 3. Are we understanding how to do that? Okay. Yes. Okay, so do these match? No, because this should match the second function. So on the question it says state if the given functions are inverses. Thank you. It doesn't match. I mean, the two equations should match right here if they're inverses. If you go through all that trouble and the inverse here doesn't match the other one, then it's not gonna. Both equations shouldn't be the same. The first one should be the same as this, and the second one should be the same as this. If it's not, they're not inverses. Okay? Now, when you're graphing, the thing to remember when you are graphing, okay, so let's look at number 17. On number 17, you will notice it's the f of, I like to make a table. The f of x, I'll make my table x, and then I do the entire thing, -1 minus 1/5 x is equal to the f of x. Shh. What kind of numbers am I going to pick here? Yes. Multiples of 5. So I'll start with -5. -1 minus 1/5 times -5. Cancel, cancel, positive, positive. We end up with what?
0.
0. The next one, let's go with 0. -1 minus 1/5. Shh. -5 times 0. Okay, this cancels out. I'm left with a -1. No, I'm left with -1. Okay, then I have the third one is -1 minus 1/5 times 5. Cancel, cancel. I'm left with -2. Now, I'm going to graph that, but for the g of x, or the inverse function, the f of -1, right? So if I'm going to make this, it's really, I don't necessarily need to find the inverse function. I don't need to find the inverse function. I can just take my table. Didn't we say all we have to do is switch? So this time x, and I'm going to make this to the inverse function. It will be 0, 1, -1, and -2, and this will be -5, 0, and 5. Does that make sense? So this is one line. This is one line. So I get -5, 1, I'll do 1 in blue, do 1 in red. Okay, -5, 1, 2, 3, 4, 5, and 0. The next one is -1, no, 0, -1. The third point is 5, 1, 2, 3, 4, 5, and then down 1. That doesn't seem like it's right. If I do the other one, it's 0, down 1, 2, 3, 4, 5. -1, 0. -2, up 1, 2, 3, 4, 5. Oops, sorry. You still should be going through the
It's a straight line.
no, it's just the way that I did it. There, okay. This is still my y equals x, right? So do you understand how to graph these? Do we understand? Some of them may get a little difficult because there's cubic functions. Just do the best you can. Make sure you learn at least the other ones. The other ones are all right, and that is inverse functions.